Okay, we are recording. Welcome to the post-merge MEV breakout room. Stefan's going to walk us through the proposed architecture, some demos, and then we have plenty of time also for questions, comments, conversations from the different client teams. Yeah, again, this is being recorded. If you're not interested in that, please jump off now. We'll have full notes and recorded available for people who want to watch later. Yeah, over to you, Stefan.
Awesome. Yeah, thanks everyone for showing up. So brief agenda. I'll just cover some of the basics of what we're trying to achieve with MEV Boost, how it fits within sort of the transition from the current MEV Geth, how it works on the network today, and where we want PBS to go. And then I'll try to get into some of the technical overview of how it works. I'll cover some of the milestones and how we plan to implement them. Then probably do a quick demo of what we have with Merge Mock running right now. Jason, if he's here, would be the right person to jump on and provide that demo. And then, yeah, we can go into discussion. And I've listed in here sort of the open remaining questions that need to be figured out over the next couple of months. Okay, without further ado, let's jump into it. So I'll just assume a good amount of background knowledge on MEV Geth. If you don't quite understand how the system works, definitely go check out docs.flashbots.net. It has sort of a good description and highlight of how it works. But basically, right, it's a Blockspace auction. It allows for outsourcing parts of the job of block construction to basically anyone in the network. And the way that it works today is with sort of this intermediary that's a relay that aggregates transactions as well as bundles, which are like fractions of blocks, filters all the like spam, all the invalid stuff, and then forwards them over to the miner. You know, it's working, right? It achieves sort of the goals that it's set out to achieve, which is providing a block space auction mechanism, but it's by no way perfect. So I've just listed here some of the properties that we're looking to improve upon with MEV Boost and with PBS. So the first one is full block bids. So right now, right, it only accepts bundles, but that doesn't allow for expressing sort of the full range of types of MEV that can be extracted or really preferences on the order of transactions. And so switching over to a system that is able to send full payloads, right, in the proof of stake context, it sort of addresses this issue. Another component is solo staker participation. So right now, the way that MEV Geth works, we're sending all the transactions over to the miner in clear text. So the miner has a view of all the transactions that are coming in, and really we're relying on a trusted relationship between the relay operators and the miners to prevent the miners from sort of stealing those transactions or, you know, censoring those transactions, inserting their own, etc. And the goal is to move away from this because it restricts the ability of solo miners to participate in this. So MEV Geth today, right, there's really only mining pools that are participating and only mining pools with a significant history of participation on the network. But we want to move towards a model where anyone can sort of just connect their proof of stake validator node. As long as they have, you know, the 32 ETH stake, they're able to connect to the system and start receiving payloads. So to do that, we want to withhold sort of the content of the transactions, not reveal them, and instead only forward over to the validator the header. So we have it sort of noted here as the validator gets the payload header from the relay, and then it's able to return this signed header. So yeah, this allows for the solo staker participation, but it also sort of adds an additional sort of trust assumption on the way that the relay operates. Third component or third design criteria that we had was client diversity. It's kind of in the name, right? Like MEV Geth was built, baked in directly into the Geth client. Whereas for proof of stake, we want to really help contribute to the drive for client diversity. And so MEV Boost moves a lot of the logic to an independent middleware. So this diagram sort of shows, right, the components that we're already familiar with: the validator client, the beacon node, and the execution client. MEV Boost sort of just slots itself in between here as a middleware and interfaces with both the execution clients and the relays for performing block construction duties. And then, yeah, we can talk a bit about the trade-offs that are involved in here. So complete privacy and trustlessness. Ideally, we want to move towards a world where the builders or the transaction initiators don't need to trust anyone when they submit the transactions, and they're guaranteed to be sort of private or at least unknown until they're included into a block and propagated to the network. Here, there's sort of an asterisk because it does improve the condition over the way that MEV Geth works, because the validators don't see the content of the transactions, but it still relies on relays as sort of being actors that aren't profiting from the content of the transactions that it receives. So that's a property that only really gets removed in the full PBS at the protocol level, where we're able to remove the relay component completely, and the builder can communicate a payload without revealing its content to any third parties. And then, yeah, trustlessness sort of works in the same way, but this is really from the validator's perspective, which is under the MEV Boost formulation of the separation. The validator sort of receives a relay receives a payload from the relay and signs it without really making sure that it's a valid payload. And instead, it trusts the reputation of the relay not to produce an invalid payload. And it's up to further validators in the network. So, validators that are future slot tenants to evaluate to see if the relay was acting malicious or properly. And make sure that the payload that was proposed by the relay wasn't a bad one. And if it was, make sure not to accept payloads from that relay anymore. So again, another asterisk, there's some improvements to the way that the trustlessness work, but it's not as good as it could be under a full PBS format. Yeah, I'm tempted to pause here, see if there's any thoughts, questions, comments before I dig into the rest of the presentation. Okay, cool. Yeah, maybe I'll try to keep an eye on the chat as well. If anyone wants to just drop questions there while I'm going through, I'll try to answer them. So this, I just want to talk a bit about how I see network topology. So I think one of the scary things about looking at this is like, wow, okay, so there's one builder, one relay, and then, they're sending payloads over to the validator. That's not really the goal. The goal is to make sure that there are as many redundant parties that are operating in each of these roles. And what this essentially enables is that if like one builder starts to do censorship or something like this, it's easy and trivial to switch to a different builder. And like the other builders will still be able to submit their transactions. Similarly with the relay, if like one relay starts to propose invalid payload for whatever reason, let's say they go offline, they have some infrastructure issue, the validators can sort of trivially fall back to a different relay. This is just network redundancies to make sure that the system continues to operating as normal. But in any case, the validator sort of locally has still the ability to fall back to a local execution client if all of this fails and all of this becomes invalid. So yeah, we've done a few rounds of iteration on how the system works. So this is kind of like the latest sequence diagram of how the messages are being passed. I'm just going to go over it quickly. I think it's useful to highlight some of the calls that are sort of standard in the engine API today, and then some of the calls that are modified to make the system work. So yeah, this is a full life cycle of a block proposal, of block construction. It starts by the engine fork choice updated call, which gets proxied to the relay, or I should say to the MEV Boost. That also sends that to execution clients and the relays. So right now, this fork choice updated is used for both like notifying what's the latest head of the chain, but also for communicating the fee recipient address that's going to be used by the slot tenant on their block proposal. Once it's time to actually produce the block, here what we've done is we've replaced the familiar get payload API call with a builder get payload header call. And basically, you know, the parameters of the call are the same, but the return values are different. So instead of returning a payload that includes the full transaction list, the relays are only returning payloads that have the root of the transaction tree. So they withhold sort of the content of the transaction list so that the validator is not aware of them until later. The other thing that MEV Boost does here is it needs to be able to compare the proposals from all the relays it talks to and the local execution client and select whichever payload is the most valuable. And it's that payload that it returns to the consensus clients. Great. The consensus client receives this payload. It puts it into a beacon block. It signs the block. We've introduced this new call, which is proposed blinded block. So this is blinded block is basically what we call a beacon block, which does not contain the transaction list of the payload. Instead, that is just null, and then but it, you know, the signature and the header of the block and the header of the payload are all still valid. So it proposes this blinded block back to the MEV Boost middleware, which is then able to route that block to the right place. In this case, it routes it back to the relay, who has the transaction list, and then it returns the transaction list back to the middleware and the consensus client, so that the consensus client can then propose it to the network. At the same time, the relay is going to propose that full beacon block to the network, and you move into the next step of the block proposal with the attestation and everything else. So yeah, I guess there's quite a bit of cover here, but the highlight is these two new modified calls, right? Get payload header and proposed blinded block, which are sort of inserted as complements to the current engine API. So great, where do we go from here? We've been working on this on the implementation of MEV Boost here under Flashbots / MEV Boost, and we sort of detail what are the different implementation milestones and what's involved with them. We split up the development into 4 milestones right now. The first one is really just about the basic logic that's required for MEV Boost to be able to communicate with various relays and be able to propose payloads to the consensus clients. And it also involves sort of the support by consensus client for these blinded blocks. So I highlight sort of the behavior and the client modifications here. But yeah, the consensus client, basically the only change that's required to be compliant with this milestone is the ability for them to accept the get payload header calls and then return a blinded block from them. So shout out to the Lighthouse team. They've been super proactive, Paul and Sean, at helping implement and provide feedback on this initial setup. Our goal right now is to have that ready for whenever Kintsugi goes live, which, to understand, we're nearing in a few days. So that'll be super exciting to have live and get some of the members of the Flashbots E2 working group also set up to run this. Maybe for context, for people who aren't aware, Flashbots has set up this working group with various different validator teams and solo validators, etc., in the community to provide a forum for discussion on both the design of MEV Boost, but also collaboration on testing of the system ahead of the merge. So we'll try to produce some package for them to get set up with MEV Boost, and I guess whatever clients support it for Kintsugi. The other thing that we have ready is merge mock implementation that supports this milestone one. So that's the demo that we'll jump into just in a few minutes. So great, we have the basic logic, but by no means are all the questions answered yet. So the milestone 2 that we've laid out here is meant to implement all the remaining critical components of the system, and those involve security. So having a fallback in the case that MEV Boost like crashes and fails over, to be able to fall back to a local execution client. Authentication, so that all the communication between MEV Boost and the relays are using signed messages, and everyone knows who they're talking to basically prevent DOS and spam. And then the third one is reputation. So even if you're authenticated with a relay, you need to be able to tell if the relay turns malicious or starts sending invalid blocks, etc. So there's some baked in logic into MEV Boost that needs to be able to identify if a relay starts misbehaving and react accordingly. So the goal for these is to have them spec'd over the course of the next month and implemented by the end of January, so that we can do further testing with those. Now there's another 2 milestones here that are worth discussing. I think we can probably skip over milestone 4, which is just about configurations, optional configurations and optimization that various validators might want to run if they have different preferences on, for example, privacy or where they want to optimize for latency, etc. So that can be sort of discussed separately. But one of the main topics I think that remains to be figured out is privacy, and by privacy I really mean validator IP obfuscation. There is a design of the system that avoids revealing the IP addresses of the validators to the relays, but it requires a lot of work with implementing custom channels or topics. I'm not sure what they're called, with libpdp. And just from initial feedback from both validators and client implementation teams, it seems it's not really such a concern for them. So this is marked as optional, and I think it'll be pending more discussion with the client teams and the EF to see if it's worthwhile to put in the engineering cycles to implement this or not. So with that said, I think it's worthwhile to jump into a quick demo of merge mock connecting to MEV Boost, and then I could start highlighting some of the other open questions that we have here and move into more discussion. So yeah, let's see. Jason, do you want to try sharing your screen?
Yeah, let me go to Whirl. Oh no, you have to stop sharing first, it looks like.
should be good.
All right, can you see my screen?
Yes, sir.
All right.
Okay, yes, we can now.
All good? Awesome. All right, so this is the MEV Boost repository. I'm just going to start up MEV Boost real fast. It's written in Go. It's very straightforward. It's relatively simple as far as implementation goes. Let's move over. So I'm going to run in 3 separate terminals. So in the first terminal, I'm going to run MEV Boost. Second terminal, I'm going to run mergemock, the execution engine. For those unfamiliar with mergemock, it's just a very simple stripped down client for both engine and consensus. It's meant for doing mock testing, mock integration testing. So I'm going to start that up, and then I'm going to start up the consensus client as well. Thing worth noting here is I'm doing one extra flag here, which is I'm pointing the engine at port 18550. That's where MEV Boost is running. So instead of how this normally runs is this communicates directly with the mergemock execution client or with a get or what have you, whatever execution clients. In our case, we're instead communicating with MEV Boost directly. So let's go back to the MEV Boost logs, and we can see it's successfully getting the payload header, and it's revealing the payload in the proposed blinded block call. So if you refer back to the charts or the documentation that Stefan showed earlier, we're no longer calling get payload, we're calling get payload header. And then in a second step, the consensus client will we'll send a blinded block and then fetch a full payload back from MEV Boost. There's some errors here you're seeing. It's not actually communicating with the relay at all. This is only communicating with the execution clients. So for the purpose of testing mergemock, this is great, right? We can see it working. We can see it working exactly as it used to with the mergemock execution client. And I think we have plans to provide more extensive testing on the relay side as well. We'll probably provide a mock relay to run locally as well. But for consensus client implementation purposes, this should be more than enough. You should be able to test the get payload and propose blinded block endpoints. And that's pretty much it. So it's not much of a demo, honestly. It's just showing that it's working and showing that we're testing it with some clients.
All right.
Awesome.
Okay, cool. Yeah, I can go back to share my screen and yeah, we can sort of open the floor up to discussion, I think. Yeah, we can either talk about some of the remaining design decisions for this this milestone 2 and have a discussion about that, or yeah, maybe let's do that. I'll just list these I'll list these open questions. And these are all things that we are looking for additional feedback on. They are currently sort of underspecified, right? They're mostly ideas, but and proposals, but hopefully they'll move to being much more concrete over the course of the next few weeks. So yeah, the first one is this validator IP obfuscation. There's a proposal for how to go about changing the way that messages are passed around and make sure that basically it's one-way communication between the validators that send basically messages to the relays and the rest of the network. And those can be done over peer-to-peer. But it doesn't really address the relays when they communicate messages to the validators, right? In particular, the most important one is getting the payload header from the relay here. So it's kind of still a question mark on how to address this, and the feedback that I've gotten is that it might not even be worth too much head scratching here because IP de-anonymization still is an issue regardless. So the option 2 is just let the validator deal with it, right? If a validator is quite sophisticated, it should be somewhat trivial for them to insert a reverse proxy around their MEV Boost client, or like run MEV Boost behind some kind of protection that even if it falls over, it doesn't affect the rest of their infrastructure. That's how miners are operating today. So I'm just assuming that would be reasonable for validators to operate this way as well. And the other option is if they disagree with this approach, then they don't necessarily need to run MEV Boost at all, and they can just fall back to running their clients the normal way without all this MEV stuff. So that's one discussion topic. Another one is fee recipient authentication. So there needs to be a way for the validator to communicate to both relays and block builders, right? So looking at this, the validator needs to be able to communicate to relays and block builders what fee recipient it's going to use. And in the first milestone, what we're doing is we're using the fork choice updated call and sending that over to the relays to communicate that. But ideally, we wouldn't rely on this, and it would be possible to just have some authenticated message that MEV Boost is able to get from the beacon clients that lists all the fee recipients that are associated with the validators that beacon client is representing. So, if the beacon client has like 1,000 validators running behind it, on startup or on connection, MEV Boost would be able to request, hey, give me all the fee recipients for all your validators. The beacon client would then request from each validator node to sign a message and then submit that back to MEV Boost, would then submit it to the relay, and then the relay would make it available to the rest of the network. That's kind of the way that this proposal works right now.
Just on that, does it make sense for validators that are using ETH1 credentials, would it make sense to just use that address? Or as an
so you're talking about, you're talking about like withdrawal credentials?
Yeah.
Maybe. The problem is I would require that withdrawal address to collect all the fees for like transactions and MEV and like even the block rewards. I guess no, in ETH2 in proof of stake there's no such thing, but certainly the transaction fees and the MEV, that's would be where like all the fees would go. So perhaps if they're comfortable with that, then yes. I think right now the fee recipient isn't like limited to being the withdrawal key.
Yeah.
So
and there's no way to upgrade currently, so it's not the full solution, but potentially becomes one. Yeah, that's cool. Thanks.
It is true that I think even if the fee recipient is a withdrawal key, you can then, like, you're not limited to withdrawing. You can still withdraw that value before stake withdrawals are implemented because
yes, correct.
You still have the key. Yeah. I guess, the idea here is that it would be possible, but not like required, right? For the withdrawal key to be the fee recipient. So the validator can pick whatever address they want. Okay.
So why do builders or searchers need to know the specific fee recipient? Can't they just use the Coinbase opcode?
So the fee recipient is what goes into the Coinbase opcode, but actually this is a really good question. So the builders, so because the Coinbase opcode is a part of the header and can be accessed through EVM execution, it also creates like you can have a code path that switches based on the Coinbase address, right? So when the builder or the relay are processing their blocks, in order for that block execution to be deterministic, they need to know ahead of time what is the address that's going to be used in the Coinbase. So there's two ways to go about that. One of them is like the validators communicates the fee recipient, and then the builder like includes that as the Coinbase address of that block, and then like submits that through. Or the alternative is for the builder to set their own address as the Coinbase address. And then at the end of the block that they produce, they just have a simple transfer from the Coinbase address to the validator address for the value of the block that they want to pay. So either of those sort of approaches should be possible. And they remain the property that, like, throughout each step, the block is fully deterministic. Okay, cool. Next point is around execution client block value. So one of the key objectives really of this system is to enable profit switching between the payloads that are produced by multiple different relays as well as from local execution client. So this step here, right, this logic where MEV Boost compares the payloads that it receives and selects the most valuable one really requires some indication of the value of the payloads. So the get payload header call and the get payload call need to be able to return an extra field that says this block contains like X ETH of delta in value for the fee recipient that is defined. I sort of talk about it here, but that message needs to be returned in a way that MEV Boost is able to compare these different payloads, just select the most valuable one and submit it. Like a further enhancement would be for this call to include some kind of Merkle proof on the balance change, which would provide potentially further guarantees. The tricky thing here is obviously it requires some changes to the engine API, and in particular changes to the data that the execution clients expose. Alrighty, next item here is fraud proofs. So because the relays are not including the list of transactions in the header that they provide to the validators are signing blindly, right? And they just presume that the relay is proposing a valid block. That's okay from like the network perspective, because once the full block is revealed, it's still up to the attestation committee to actually validate if the block is valid. And so the network will never finalize an invalid block, but it does cause the validator to lose the value that it could have received from both the MEV and the reward for the block proposal. And it basically just get a missed slot in the chain. So you want to have a system where other validators can notice. So let's say, this is the path that's taken. You get a bunch of transactions. All the relays propose a block to the validator here. And this is the validator of slot 1. This is the validator of slot 2. This is the validator of slot 3, slot 4. If the validator receives an invalid payload from the relay and submits it to the network, you want the validator number 2 to be able to notice, oh, wow, like this relay proposed an invalid payload. Even if he sends me a payload for my slot, I'm going to ignore them and just switch to using the other relays. And the way to do this is using sort of this fraud proof message. So because all of the relays and all the validators are listening to the latest state of the beacon chain, what you need is the validators to be able to communicate back to all the relays, hey, here's the payload that I received from relay 1. This is the one I decided to include in my block. I can prove it because they signed it. And then all the other relays are like, okay, now we can validate to see if this payload was correct or not. If it's incorrect, what they want to do is send this fraud proof message to validator number 2 that says, hey, look, relay number 1 proposed this payload for this block height. You can see that it was invalid because you can see the state of the beacon chain for that block height. Therefore, you should no longer accept payloads from this relay. So this fraud proof system is sort of what keeps the MEV Boost protected sort of automatically from relays that turn malicious, but it requires to be further spec because there's likely to be some modifications to the way that it validates those payloads, both with the local consensus client and with the local execution clients to run smoothly. And there's a few approaches to doing this, so it's worth sort of calling out as one of the remaining discussion points. Okay, if you're still there, if you're still bearing with me, the final one is splitting away the execution payload call. So one of the components I mentioned in milestone 2 here is a security. So under this description, right, the beacon client is only communicating with the local execution client through MEV Boost. But really what you want is a situation where if MEV Boost goes offline for whatever reason, it has some software fault, the beacon client is still able to operate all its duties by falling back to communicating directly with the execution clients. So this is just about making sure that this exists in all the beacon nodes, so you have that level of redundancy if there's a complete system failure. And yeah, that's it. That's all the discussion topics that I have. I've listed some resources down here and some notes that Paul has put together while we were iterating on the work that we have so far. So definitely encourage everyone to check those out.
Cool, thanks. Yeah, so I'm Paul from Lighthouse. As mentioned a couple of times, I've been working with Flashbots on it. I thought maybe I would just talk for a little bit about what I've been working on with it. So I'm on Lighthouse, a developer of one of the consensus clients. So I've been trying to get involved with Flashbots to just make sure that this can be as safe as possible and that we can also maintain the concept of client diversity. So we're kind of, when we bring in something like MEV Boost, Flashbots, we kind of become at risk of centralizing upon this thing, not necessarily from like a governance perspective, but more from like a piece of software that can fail and take everything down sort of perspective. So the designs reflect that now. Something I've been trying to make sure is that we have the ability to fall back to our local execution node, like, Nethermind, Geth, whatever, if things stop working. And also what I think is very important as well is to not rely upon MEV Boost for validation of payloads. So they'll give us a payload and we always verify it with our own node so that we can, that basically stops MEV Boost from being in a position where we can finalize completely invalid transactions and things like that. So that's kind of what I've been working on, as well, is trying to make sure that it's multi-client compatible from a consensus client perspective. So try to make it so that it's easy to implement for consensus clients and make it so that there's a clear path to doing that, so that it means that we can get all of the consensus clients that are interested in implementing it, can get them on board with a pretty low barrier to entry, so that we don't end up with a scenario where, if you want to run MEV Boost, you need to run some client, and therefore will skew the network. So yeah, it's been great working with the Flashbots team. I'm looking forward to being involved more. Yeah, and if anyone, especially from the client teams, have any questions or want to talk about it, my door's always open. Thanks.
Cool. Any other thoughts, questions?
What's the best way for folks to reach out to the Flashbots team as they're starting to look into this and like have questions and whatnot?
Yeah, good question. So there's a channel on the ETH R&D Discord called Block Construction under Execution R&D, and I'm always keeping an eye on this thing for any messages. So if you need to reach out to Flashbots, you can just at the ghost up there, and I'll see it.
Thanks. Lucas has his hand up.
Yeah, I have a question. So as MEV Boost is kind of this middle layer that's between something that produces the block like an execution engine, but we still have an execution engine to fall back to, right? Would it make sense to like bundle it with an execution engine process? Like, for example, Nevermind has this plugin ability. Would it be good to have a plugin for MEV Boost that would think so next with the execution engine can have a look at the current state of the network from the execution engine perspective, as well as communicating to the revamp?
Yeah, I think this is kind of like an open question of like how deeply can MEV Boost be integrated with both the beacon nodes and the execution clients. We've tried really hard to comply as closely as possible with the way that the engine APIs work today, so that it's like cross-client compatible by default. That being said, I do expect that there's some advantages to having deeper integrations. We haven't spent that much time looking into it, to be honest. We've just been focused on how to make this thing as stable as possible and like broadly compatible as possible. But yeah, I do expect there could be some advantages to integrate further.
Yeah, the beauty of it, it's abstract, so it can be integrated in the exchange, right? So that's the idea, but the integration part is still part of the question. Maybe there are benefits to that too.
Right, like you could definitely, I think, implement all of the MEV Boost logic as part, like as a module on Nethermind, right? Probably, and then you wouldn't have this like other piece of software that's running in between. You would just have the execution client that's also talking to our relay. And it ends up looking much closer to the way that MEV Geth is sort of architected, right? But you do like remove the need to have this this other piece of software. So if like client teams want to explore that and just replicate all the logic, I think that's something interesting to look at.
Any other questions, comments?
I have some.
How
can we make sure that the builders and the relays are not the same person? I think if you run a successful relay, or like if there's a cost for validators to like be at multiple relays in terms of whatever, setting it up, bandwidth, whatever, then they would probably only go to a couple. And like, how can we make sure that those relays are not, I don't know, getting bribed out of band by the builders?
Yeah, that's a really good question. So I can say how I sort of expect the industry to like work around this and like respond to this. Yeah, let me talk a bit about this. So I think, as everyone here is aware, right, like not all validators are solo validators, right? They're running both their validator client, their beacon client, and their execution clients. But in practice, while there are some individual solo stakers who do this, you know, a big chunk of the proof of stake network right now works by either people running their own validator client, but then outsourcing the beacon client and the execution client to some infrastructure provider, or pooling together and staking pools where they don't control the validator client either. And so there's sort of an industry that's propping up around various different actors running different segments of the system, right? Like even solo stakers who are running their validator client and beacon client are still outsourcing their execution clients to Infura, right? So each component is sort of set up to be bundled together with each other in a way that provides a service that might be interesting to some users. I do expect somewhat similar thing to occur in this level of abstraction. So while there will be builders who just focus exclusively on building because that's where they have their core competency of being able to merge transactions together, being able to find some MEV and produce blocks with it. There will be others who say like, oh yeah, we don't want to trust a third-party relay who will see the content of the blocks that we produce, and so we'd rather be able to just communicate directly with validators. And so they will try to run their own relay as well and get as many validators as possible to sign up for their relay. Similarly, I do expect that some of the large validators will say, well, we think it's a big risk for us to sort of trust all these third-party relays. So we'd want to also run our own relay such that we can see the content of the payloads before we sign off on them, and we're able to validate them. And so we don't need to worry about this, this fraud proof mechanism, but instead we can just sort of operate very similarly to the way that MEV Geth operates today, where you have full information and you can just sign off on blocks. But it's really probably only going to be the large validators who do this. And an example of this is Ethermine, who has been running, in the proof of work land, both the relay and their miners. So I expect they'll probably continue to do this. But there will also be these sort of individual entities that are incentivized to run relays. So within the Flashbots working group right now, there's 3 entities that have indicated some interest at doing this. So one of them is Blockspace, who they are currently running a relay for the proof of work version. They'll continue to do this here. There's a consensus that's indicated they perhaps want to see if this is a product that would make sense within Infura, and then Alchemy as well have indicated some interest in exploring this. So I do think there are some entities like those whose business model is very much so on being an infrastructure provider, whose role is quite fitting to run this relay infrastructure. When you think about what running a relay really is, it's opening up some endpoint, right, to as many people as possible, as many users as possible, to receive a bunch of different block proposals, doing some highly scalable simulation of these blocks and verification of these blocks, filtering out all of the garbage, and then only submitting the best ones over to the validators. So that's pretty similar to a role that Infura does right now by receiving a bunch of transactions from users and then only submitting the ones that make sense to the transaction pool.
And another thing, so regarding the issue that we need to know the value of the payload produced by the local execution client, if we have a standardized format for paying the block producer, okay, no, that doesn't do well.
So I don't
like the MEV Boost knows the transactions, right? So if we had a standardized format to create a transaction that pays the fee recipient and put it in, then we would know how much someone would be willing to spend. And so we could gauge MEV based on that, right?
Yes, that's right. Actually, I'll shift over to here. I mean, I have one line on here that describes it, but it's something that's worth talking about. There's this line on milestone 4 that says, consider adding Merkle proof of payment, to shift verification requirements to the relay. So basically what this means is, instead of leaving the option for the builders to set their own Coinbase address, or use the fee recipient as a Coinbase address, it would say, okay, no, builders always set their own Coinbase address, and they include a transaction at the end of the payload that pays the fee recipient. And then what they can also do, then the relay can produce this proof that that transaction was included and has the right precondition on the balance of the builder to be able to complete the payment to the fee recipient. So this would involve, standardizing the way that the payments are made, and then you can create this proof that the payment was included, and then attach that to the header, to the payload header when it's communicated to MEV Boost. And then in theory, the execution client can do the same. I think if there's a way to avoid this level of deep constraints and maintain the ability for the builder to set whatever they want as a Coinbase address, and simply say, this is the change in the fee recipient balance, and have that be sort of self-standing without restricting how the payments is made, then that seems ideal in my mind, because it's less restrictive.
Yeah, but it adds some complexity to block building, and it also adds complexity to people that are not using MEV Boost, right? Because they have to opt into this to the same API. I would be okay with having this as an optional field in the payload, in the get payload object, but not having this required.
Yeah, I think that's fine. Yeah, it seems fine for it to be optional. Yeah.
Any other questions, comments?
I have minor question about last chapter, relay fraud proof message. What would happen if relay just not revealing the block in the end of all this interaction? Validator risks to just miss the slot, right?
Correct. Yeah. So in this initial post, right, that describe this architecture, we list 3 ways that a relay can misbehave. First one is just producing an invalid payload. Second one is misrepresenting the value that the payload has. And then the third one is missing data. So just never revealing the transaction list. So there isn't really a good way to do a fraud proof for that, right? Because it's just based on timing. A relay can claim that the message came, but just too late, and can just stall it out or whatever. So I think this can be much more subjective. Maybe it has to be a statistical approach where, if a relay misses more than X number of slots within, Y amount of block proposals, then it becomes disabled. That's my idea. I'm wondering if, what you think of that.
Yeah, thank you. Yeah, I think it's can't be solvable without like completely off chain. Maybe like some complicated mechanics, but it would complicate things. But yeah, it's like still like a possibility of attack. This kind of attack, not revealing the payload in the end of all interaction. But yeah, I think that good relies. It's not interested in doing this.
I had a question kind of based on what you guys just discussed. So you mentioned like disabling malicious relays. So who controls like what's a valid relay or not? Like, is there a master list of active relays that's controlled by whom?
So there isn't. The way that it will work is basically the validator, when they start up MEV Boost, they can define a list of relays that it wants to connect to. And so the validator is always in control of which relays it wants to communicate with. Something that we've discussed in the past is, does it make sense for, like, there's always a question of like, what are the defaults, right? Like, does it default to like no relay? Does it default to a single relay? Or does it default to outsourcing to like a list that exists somewhere? We haven't really decided on this. I guess that's like open for discussion. Something that like might be useful for like solo validators is, I don't know if you all are aware of like token lists. Like if you've used Uniswap, right? Like instead of Uniswap coming up with a list of valid tokens, you know, the ones that aren't malicious tokens, and making a decision themselves, they allow for like any third parties to submit a list and like maintain their list of tokens. It could be a similar system here where the validators can delegate to a third party list that's curated by, you know, some entity that carries some reputation and who focuses on exclusively verifying the activity of the relays. But really the goal is for always maintaining the ability for the validator to define which relays they trust.
Okay. I guess that makes sense. It just also causes like a potential problem. Like if you're trying to punish like malicious relays, but really it's a permissionless system, then they could just probably find another way to get back on a list or whatever. Obviously it's more difficult, but
yeah, it relies on this reputation, right? So if the relay does something malicious, super malicious, and then they go offline and then like spring back up with a different identity, it's kind of up to all the users in the network to try to identify that. If the user using like a third party to do this like reputation check, then you'd hope that third party would be able to identify that too. So it's certainly a risk. Like a relay could attempt to go this direction, but I expect over time, as they build reputation, that's sort of a sub cost, and they aren't necessarily incentivized to validate that.
And like the remedy or fallback mechanism for like a potential, I don't know, mass denial of service attack against relays, like obviously at some point that's just disabling MEV Boost, but is there any other way to do that, or like the IP is not even exposed?
Definitely the like fallback mechanism, if all the relays go down, is like MEV Boost still talks to a local execution client and is able to produce blocks that way. Yeah, if every single relay goes down, yeah,
but like if some go down and then the ones that are around just give bad blocks, that's kind of like how I'm imagining it.
Yeah, so you could have like an extended period, like let's say all the relays at the same time start producing bad blocks. Then you would have like a cycle where validators like one by one disable the relays,
right?
And so maybe like just thinking about it, the longest amount of time that the chain would go is like the number of like relays that are enabled by all the validators. So ideally, right, you have validators that all have like a different list of which relays they trust, and then you have a bit more like diversity there.
You don't want like 100%
maybe
overlap between all of the shared relays.
correct. Yeah. But yeah, worst case scenario, I think that's like the block, the chain misses the number of blocks equivalent to the number of relays after malicious.
Mm-hmm. And are relays able to provide like malicious blocks as opposed to just invalid blocks? So when they get something from the builder, is that like a fully, I don't know how to say it.
A fully what, sorry?
So like obviously they can either like not respond with a block, which is the same thing as responding with an invalid block. But is there a possibility that they basically respond with a block that's like not been built by a builder and they just come up with their own thing and it's like a bad block in some way?
Yeah, so I can dig into like the 3 ways that a relay can sort of do something bad. So the first one is just like it tries to like send whatever a transaction from somewhere that like doesn't make sense, or like just contains some, you know, some logic that doesn't work, like the header is misformatted or something like that, right? So the payload can just be invalid. Another one is like inaccurate value. So something that a relay could do is, you know, the block that it's actually producing has 1 ETH worth of value that's being paid to the validator, but they claim that there's 10 ETH worth of value. And so, you know, they can basically guarantee that they win the profit switching here, even though the block that they produce wasn't that valuable. So I say that's probably like a clearly malicious thing that like wouldn't happen by accident, is over reporting the value of a block. So I'm wondering if that's what your question is.
Yeah. No, that makes sense.
Anything else? I see a couple people are still unmuted. If you have a question, comment, just jump in.
I had to step away for a minute to get a computer that arrived at the door, but I posted a question in the chat. Did you guys answer it already? A couple of us were wondering, we were chatting on the side. Are relayers incentivized separately from the builders?
So it's not defined within the system. You know, actually, neither is the builder compensation, right? I sort of propose like the way that I think builders would likely want to monetize, which is they set their own Coinbase address and then they like have some payment and they can keep some delta between the two. And still their incentive is to pay the most that they can because they're competing against all the other builders and producing this. I expect Relay's business model to be more fees oriented. So if we just think about how like Blocksroute operates today, right? They have like a fee per number of messages that it inputs, and you know, obviously Infura and Alchemy have a similar system where they just charge by like API calls. So I expect those to be the like likeliest monetization routes for the relay.
Is it possible for the relayers to take some cut of the deals as they pass them through so that they're competing in price discovery like the builders?
Maybe, though I don't see that being super stable. Like basically it would require adding additional transactions somewhere where the relay would say, you know, we only accept blocks from builders who like pay us within the block that they produce. And then they would like then forward the payment on by adding their own transaction at the end of the block to the validator. So it could be doable. It could be doable. Feels somewhat less likely to me, but it's a possibility.
Okay. All right. Thank you.
I was wondering, so what is it that's missing right now that makes us need the relays in MEV Boost, but we won't need them later when we have the full PBS?
Yeah, good question. So we had a discussion last Friday where Vitalik presented PBS and like the properties that it has. So it's called MEV Roast. Maybe there's a way to surface a link to that, but I definitely recommend checking out that talk. Basically, what you need to remove the relay completely from the system is the ability for the validator to accept messages from any builder. And to do that, you need to have unconditional payments attached to a payload. So right now, the way that it works is the builder creates a payload and submits it through. But if the payload is invalid, right? If the payload reverts for whatever reason, the validator doesn't get paid. But under to have all the properties that you want to be able to remove the relay, you need to have this be completely independent, where even if the block that the builder proposed is completely invalid and reverts or like just never gets accepted, the payment from the builder to the validator still settles. And that creates sort of the counter incentive for builders to produce invalid blocks. It like prevents the DOS and spam issues. And then you can handle basically making sure that you continue mining on a valid chain by updating the fork choice rule of the chain. So that's how PBS sort of handles this issue.
Awesome, thanks.
Anyone else? Okay, well, yeah, if there are other questions, comments, as people look into it, like we mentioned earlier, the block construction channel is the right place to discuss this. Thanks a ton to the Flashbots folks for coming on, presenting this. Yeah, agreed with the comments. This was really helpful. And yeah, thanks to everybody else who attended, asked questions. And yeah, I guess we can wrap it up. We'll have a recording for this and I'll share it on the Discord as soon as it's ready.
Awesome. Thanks, everyone. Thanks for the really great questions. Yeah, looking forward to chatting some more on all of this.